Hello, I'm John Joshua Belonia and here once again to perform an experiment. Experiment number 5, 8-bit analog input. So, as per usual, we need to first create a new project. So, we'll create a new project, standalone project. Make sure it's PIC 16F18875 with the XE8 compiler. So I'm gonna browse towards new a folder here, experiment 5. I'll name it XP5 finish. So now we have XP5 here. We're gonna go out to activate our MCC. We'll go ahead and select MCC Classic and finish. Okay, so for now, we're gonna go on our peripherals, which which is here. We're gonna click on ADCC. So we're gonna click it and add it. So as you can see, the ADCC is now loaded along with our other stuff. Now we'll go ahead and click here on RA4 as our pin module output. So we have RA, this is 4. And then we'll go ahead in RA0, but here in the ANX and click it so that it would turn green. So we'll go ahead to our pin module. So here is our pin module RA4. We will rename it as D2 LED. This is a digital signal and it's an output, of course. Then for the ADCC, we're gonna change it to just the potentiometer, the pot A0. So this is an analog input, of course, because this is the port at which the potentiometer will be basing on. Then we'll go ahead to our system module. On the same settings, we'll still have 4 megahertz with the divider by 4. And we still have low voltage programming enabled. And then let's move on to our ADCC here. So we need to have the result alignment to right, the positive reference as VDD, negative as VSS. Okay, so our clock source, if is still that, the default one, well, also our clock would be the default one also. Also, the ADC should be enabled. If I were to be asked what is the meaning behind ADC, I would probably guess it would be analog to digital converter or conversion. Now, we can now generate our code. So here, we're just gonna have it generate and wait. So we have here generation complete message. Now, it's time for us to change our main code. So under the files, we'll access our current experiment on main.c. So we'll just skip these parts. So in this part, we'll add here our code. So our code would be to first, of course, is to initialize our ADC module. So first, we'll type in ADCC should be initialized. So initialize, then the usual combo. After that, we'll ask if it will convert the value that is analog and compare it to 512. The reason for that is that because the analog signal will be comprised from a value of 0 to 1023. So if it is turned all the way counterclockwise, it would be 0. If it is turned away to clockwise, then it is 1023. The halfway value would be 512. So if we move it more to clockwise or counterclockwise, it would have this comparison. So first, we'll have this if block. If the ADCC will get the value, but it's of course the converted value of red already. So is the converted value of the potentiometer or the port where the potentiometer is, which is port, the name of the port is pot A0. So if that value is less than 512, that is to say, if it is turned more inclined to the counterclockwise, then we will set the diode, the D2 LED will be set to high. If it is not the case, else, then the diode D2 LED, let's scroll down, would be set low. Low. Okay, so we can now build this code. Building it. So the build failed. So as we can see, there is a warning here at this line, and this is this function is pointed out. So we're gonna go ahead to our MCC generated files and access our header file for the ADCC to search the right function for this. So we're gonna skip this. So we're gonna find the ADCC. Okay, here's the ADCC initialize. That's good. Start conversion. Is conversion done? Get conversion result. Returns the result of a analog to digital conversion for requested analog channel. So this is probably the function that we want. So we'll just have to add the result here. So getting back here, so we'll have to add the result here. As you can see, the red underline is now gone. We'll now attempt to build our code. Building it. Still, there's a build failed. Since our build failed, let's search for another function in the ADCC header file. It's not this, so we'll try the next one, which should be this one. Get single conversion. So if get single conversion, we'll try to build it. Let's see if it works this time. So the build is successful. Now that we have our build, let's head over to our IPE. So our IPE is already here and our PIC-Kit tree is already connected. We just have to browse our hex file. So our hex file would be at experiment 5, this default production experiment 5. So it is now loaded. We can now program our PIC-Kit tree, programming it. Now it's programmed. We can now disconnect our PIC-Kit tree and go over to our circuit. Okay, so this is our circuit here. So I've already connected the potentiometer here to the power supply. Of course, here the ground, and here is the input to port RA0. Is this port RA0? Yeah, this is port RA0. So holding it down. So if we move the potentiometer all the way clockwise, it would be positioned as greater than 512 or 1023. So it would be set low, as you can see now. So if I turn it all the way counterclockwise, it would have a value less than 512, which is 0. It should turn on. So now I'll turn it counterclockwise, and you can see that the LED has turned on. So if I turn it again clockwise, it turns off, but I didn't turn it away all the way, so I can just turn it back in with just a little shift. Then so this is where the 512 value is. So it lies between this very short portion of the potentiometer. As you can see, my fingers are just moving just a bit, but still the LED is turning on and off. So this is working as intended. I move it all the way clockwise. It set low. So if I turn away counterclockwise, it would be high. So that's all for the experiment number 5.